Okay, so today we're going to be talking about carbonyls, and I'll go ahead and draw, I'm going to go ahead and draw one. So this, how it is, would be a ketone, since this would be a carbon and this would be a carbon, but if we change one of these to a hydrogen, then we have an aldehyde. So as far as reactions with these compounds, you can really break it down into what type of nucleophile is going to be attacking this carbon right here, since it has a delta positive charge. So starting with a oxygen-based nucleophile, we can attack this aldehyde with water. So yeah, we can react this aldehyde with water and acid, and here we have our H plus ion, and that will give us this geminal diol compound. So we can also replace this water molecule with Cn minus, and it would give us a cyanohydrin, which is this compound right here. So obviously this is not an oxygen-based nucleophile, but the H2O was, and that is one example of our oxygen-based nucleophiles. We can also do, we could also react this aldehyde with an alcohol, and if we have our one equivalent, it will make, not that compound. So yeah, one equivalent of an alcohol with this aldehyde, this oxygen will attack this delta positive carbon, and the OR will add, and this double bond will break off, and the oxygen will get protonated, and we're left with this hemiacetal. And now if we react this again with the second equivalent of alcohol, we actually get a full acetal, or otherwise known as a ketol. So as far as hydration reactions go, we can also do them with a base. So here we just use the basic hydroxide ion and our aldehyde. So the first intermediate we get is this compound, where we have an alcohol and this oxygen ion right here. So we react that with another water, and the oxygen obviously takes a proton from the water and makes our geminal diol, once again, that we saw in the first reaction with H2O and acid. So what we would get if we did a sort of reaction like this, where we do have two equivalents of alcohol. They are just on the same molecule. So say this alcohol would attack first and add to this carbon. This alcohol would still attack second, and we would end up with a product that would look, oops. So here's one of our alcohols that added. Here's another one. But they're connected with these two carbons. So we'll go up for one carbon, up for another carbon, and then we'll, move this across. And I didn't actually draw our alcohols in here. So obviously the hydrogens on these alcohols would be deprotonated, and this compound would be stable. So that's a great way to form cyclic compounds through this carbonyl group and adding two alcohols on the same molecule. Okay, so let's switch and talk about a slightly stronger nucleophile, which is nitrogen. So nitrogen as a nucleophile will be in the form of amines. So here we have a primary amine, and you know it's primary because it has 2 hydrogens and it's only connected to 1 carbon right here. So if this reacts with this aldehyde, we will end up with our carbon attachments, and then we'll have our nitrogen, and that will be double bonded to our original carbon that was in the carbonyl group. So this is the carbon that is right here. And the rest of this was just added on, and we have this double bond with our nitrogen that we formed. So this group right here is called an imine, and in a second we'll see a very similar sounding word for the result with secondary amines. So now we have this secondary amine, which only has 1 hydrogen attached and 2 bonds with carbons. And this will actually react a little differently with our good old carbonyl here. So we actually form this product right here, which is called an enamine. And you can see we have the addition of an alkene to a carbon next to this nitrogen. And this here is our aldehyde. So we have 1 carbon, 2 carbons, and we have 1, 2 carbons. Our oxygen is no longer even in the molecule anywhere. So that will actually serve as a leaving group when the double bond here gets removed when nitrogen attacks our delta positive carbon. So this oxygen will gain electrons and end up taking a proton from NH4, and then the hydroxide ion will serve as a leaving group and be banished from both of these molecules. That is pretty much the mechanism for both of them. But if we have an acid like sulfonic acid, or that as a group on a molecule, then we will actually have a bit of a different mechanism where the OH forms before the nitrogen adds to our carbon. But anyways, so now we have carbon as our nucleophile here, and this carbon has a negative charge on it, and it's obviously an alkyne. And this works because obviously this negative charge really wants a positive charge that's in this carbon. So it is going to add, and it's actually going to so it's actually going to chop off this, the rest of this compound right here. This CC bond is going to break, and we're not going to add these 2 carbons. So our final product is going to look like, hold on. So yeah, this is going to be our final product here. We're just adding our alkyne. This is our original carbon, and this carbonyl turned into an alcohol. Alright, so now let's talk about the Grignard reagent, and that's this MgBr we have right here, and you can get this by adding magnesium to an alkyl halide, in this case bromine. So yeah, what we're going to get out of this is the following. Alright, so this may be hard to see because of the way I drew it, but this would be the resulting compound. This is our oxygen, this is our original carbon right there in the middle, And then these 4 are these carbons here. The magnesium bromide just gets chopped off in the process. We don't really want that on there anyways. So that's a great way to make new carbon-carbon bonds using this carbonyl and the Grignard reagent. So let's try this reaction too. So here we have our aldehyde and an organolithium compound and acid. So this is going to react, and we're going to get our original carbon, which will be right here, and we're going to add, oh no, okay, ta-da! This is our final molecule. Obviously, the lithium ends up being a leaving group and doesn't end up in the final product, but you can see we have formed an alcohol and we have added a new carbon group or an R group. So actually I think I'm missing a carbon, maybe. No, I'm not. Okay. Anyways, that's what we would get from using an organolithium compound. And we're still looking at how we can get carbons to attack this delta positive center. And a lot of times it's difficult because carbons want to be stable, and to get them to attack something, we kind of need to make them unstable for a while. That's why you see this working, because basically you need these attachment groups to make this carbon able to attack. Yeah, so, but yeah, I pretty much went through everything. Maybe I didn't go through everything actually. But yeah, that's basically how you can categorize reactions with carbonyl groups. You can just look at what the nucleophile is. If it's a carbon, well, it's going to have some attachments. If it's a nitrogen or an amine, it's going to follow one of 2 ways, depending on if it's a primary or secondary amine. And if it's an oxygen, like water, it's going to form a hydrate. And yeah, so pretty straightforward. I would keep talking for 15 minutes, or until it hits 15 minutes, but I don't think it's necessary because I got through everything. Yeah, so that's good.